Yeah, thanks. Thanks everyone for sticking around this afternoon. I'm happy to have this opportunity to talk to you today about the San Rafael Restoration Project. I'm a postdoc at Utah State University. And for those that aren't familiar, just because I forgot to put a slide in today, the San Rafael River is a tributary to the Green River. It starts up in the Wasatch Plateau, flows down through the San Rafael Swell, and hits the Green River in between the town of Green River in Utah and the Canyonlands, and where the Green hits the Colorado. So just to give you an idea of where that is. I want to start out today by acknowledging my co-authors, Justin and Phaedra. They really got this project going and have been instrumental through the whole process of developing this restoration plan. Maybe it's this one. There we go. Okay. So over the last year, we've been developing a restoration plan focused on improving populations of native fish and riparian vegetation on the San Rafael River. And this really represents a culmination of multiple years of research that went into this and management efforts. It was a highly collaborative project between the BLM and the Utah Division of Wildlife and Utah State as well as a number of other people. And it was developed, it's a large-scale restoration plan, and we're really looking at it as not just a restoration plan for the river, but as a long-term management plan for moving forward. And so if anyone's interested in the plan, having a copy of it, just come grab me after the session. I'd be happy to share that with you. But what I'd like to focus on today is just how we were able to incorporate information, incorporate the scientific data that was out there about the river, working with scientists and managers to develop a restoration plan that was implementable on the ground. And so, I want to give you some lessons learned that we found, and some steps that we took to develop this restoration plan. Hopefully, as to provide some insight for those that are trying to develop science-based restoration plans for wildlife or vegetation or whatever it is. Okay, and to start out, a key thing that we found that helped us out in developing this scientific restoration plan was to adopt and work through this systematic planning process. And this diagram shows, this flowchart kind of illustrates that planning process. And if you saw Anna Scher's talk yesterday, she put up a similar diagram and emphasized this similar point. We've modified this just a little bit. The main difference that we have here is that we developed this plan within known constraints on the river system, both ecological and non-ecological. And that was really critical because we wanted to acknowledge those constraints up early so that we could work with them to address them rather than having them be implements to moving forward. And I'll talk a little bit more about that later on. But what I'd like to do today is go through this planning process and talk about these, just show you the example that we did and talk about how we were able to work through each of these steps on the San Rafael planning effort. So a major focus of the restoration plan for the San Rafael River was to improve populations of these native fish species. So the flannelmouth sucker, bluehead sucker, and the roundtail chub. They're all species of conservation concern in Utah and range-wide. So there has been some great research by some master's students at Utah State University, and they really found that populations in the San Rafael River are structured in a source-sink manner. So up in the upper San Rafael River, the populations are doing well, and they're providing a source of colonists to the lower river where the populations are not doing well. They're not maintaining populations. They're dependent on immigration from the upper San Rafael River and the Green River, which the San Rafael flows into right there. So the main thing here is that the three species are not doing well in the lower river, so that's really where the focus of our restoration efforts are, is trying to improve populations in that lower river. And there's a number of reasons why the fish populations aren't doing very well in the lower river, including the presence of non-native species, fish passage barriers, and periods of dewatering. I don't think that's working. There it is. Oh, that's So those are main issues, and we've addressed those in the restoration plan. But what I want to focus on today is the habitat loss within the lower San Rafael River. This is really a major issue for these fish as well. The habitat has been really degraded over time. If you saw Mike Scott's talk yesterday, it's a similar situation to the Escalante River. There's been a loss of spring floods over time since the early 1900s. But at the same time, there's been a lot of sediment still moving into the system. So we've had a loss of flows and still an input of sediment, and so that's led to a really dramatic channel narrowing over time. You can really see that in this. This is a historic photo taken in about the 1920s. Notice these bridge pilings from this old bridge. Those are circled in red in this lower photo, and so you can really see the channel used to be expanding that whole width. Now it's really narrowed and into this ditch-like system, and that's really poor habitat for these native fish. So that's really something we're trying to address with this restoration plan. Okay, so that's really getting at the causes of degradation. That's why the fish populations are doing poorly in the river, and that was, using that, understanding the causes of degradation, we wanted to combine that with an image of what we want to see the restoration plan look like, at the end of the restoration plan. So we wanted to combine those two, and then use those to identify conservation and restoration goals. So just to talk a little bit about the guiding image, what that is really just getting in your mind what do you want to see after restoration is done? What's the long-term prospects for restoration? And in our case, we really wanted to strike a balance. And an important thing is that this should be, you should have this in mind given the constraints that are on the system. So in our case, we're ecological and non-ecological. The climate is changing. We're not going to have the same flows that we had back in the 1900s. There's water use in the basin. That's not going to go away. So we really want to acknowledge those in defining what we're looking for in terms of restoration. So in our case, we struck a balance between those, and we said, well, we're not going to make it back to the early 1900s and have this wide channel, but we still need these dynamic processes that were really creating this habitat and maintaining fish habitat at the same time. So we were just trying to strike a balance there, and we came up with this image for what we wanted to see in terms of long-term restoration. We wanted to see a dynamic river system providing necessary and sufficient habitat to ensure persistence of native aquatic and riparian species. And so, understanding what we wanted to see the restoration plan look like in 50 years, understanding what the causes of the degradation were, we came up with these restoration goals. We had 4 restoration goals. We wanted to encourage self-sustaining populations of native fish, and understanding the population structure, that source-sink dynamic, is really important in formulating this goal, because we knew that we needed to improve connectivity within the river system in order to maintain that source-sink dynamic, and connect and allow there to be colonists down to the lower river and connect those two populations up. And then that will help increase the native fish populations. So we also had goals of ensuring persistence of native riparian vegetation within the river system, and we wanted to provide necessary and sufficient habitat for fish and vegetation as well. And I think this was an important thing that we did with the restoration project. We incorporated monitoring as a project goal. So we stated right there up front in the goals of the restoration plan, to get monitoring integrated into the plan right from the beginning, so that we can really focus on this being an adaptive management plan over time, and really put effort towards monitoring as part of the restoration plan. Okay, so those are the restoration goals, but those are fairly broad, right? I mean, here we're saying we want to conduct monitoring to assess, whether the goals are being met. That's pretty broad. Conduct monitoring. How are we going to, what goes into conduct monitoring? So that's where our objectives were very specific and measurable. And we had 7 project objectives that we stated. I'm not going to go through them all here. Essentially, they range from habitat degradation, addressing habitat degradation through monitoring. But the key point of these objectives was that they were specific and measurable. And just to give you an idea of what we mean by that, This is one of our objectives related to habitat. So, the language here is 10 to 20% of the reaches on the lower San Rafael River will have greater than 30% complex habitat, and so on. And that may not mean a lot to you, but the point is that we have specific numbers here, 10 to 20%, that we can monitor over time. Are our restoration actions accomplishing those objectives, so we can really understand if the project is being successful or not. So once we had the goals and objectives established for the restoration plan, a really important part of this planning process is to prioritize sites. And if you heard some talks earlier, Glenn and those guys did a great job of showing how you can prioritize sites on the Gila River and the Virgin River. We used a little bit different methodology because we were focused on restoring for native fish. But an important point that I want to emphasize in site prioritization is just the importance of identifying not only the areas where you want to do restoration, but the areas of where you can do conservation. So where are the areas where you have native fish habitat, where native fish populations are doing well, where the riparian vegetation community is in good shape that you don't necessarily need to apply restoration to. That was a really important part of this planning process. And so we use the methodology. I'm not going to go into detail here. If anyone's interested, I can talk about it later. But we used we used information on known habitat, on known fish habitat and riparian vegetation communities to identify areas again where they're looking good, where we don't need to do restoration, and then also identify those areas where we want to do restoration. And we were able to rank those from high priority to low priority based on where we expected to have the greatest benefit for native fish. And so this resulted in dividing up the river into 15 different sections or reaches. This is our project area, so it's about 90 kilometers long. So taking that all on at once would be a big task. But through this prioritization area process, we're able to break that down, and we can use a phased approach over time. We're going to use a phased approach over time. Taking on a section or two at a time, and testing out restoration actions and moving forward from there. And again, we identified a couple of conservation areas where we had complex habitat and intact native riparian vegetation communities, and this just kind of gives you an idea of what those look like. We have this nice pool, riffle habitat that's useful for native fish. And then we, for the first stage of restoration, we identified 5 areas where we really have degraded habitat, but we really think we can have a beneficial impact for native fish. And so that's where we're going to start restoration, and again, apply techniques to those priority areas and then move forward over time. So once we had sites prioritized, we moved on to this next step of identifying site-specific tactics. So what are we actually going to do on the ground to restore habitat? And in order to do this, it is really important to assess your costs and risks and weigh those versus the benefits of different actions. And for us, we really wanted to. We felt like it would lower costs and reduce risks and have great benefits to work with the natural processes that are working on to supplement those. Not just design the channel and put in habitat. With a lot of equipment and stuff, but really try to work with the processes that form habitat over time. And so we have a number of actions that we're going to be using on the river system, and I'll go through those briefly. But again, they're trying to work with processes that maintain fish habitat and vegetation over time. So the first one is tamarisk coal tree removal, and just to give you an idea of what we're hoping to accomplish with this is. I'm able to show you this because there's been a lot of great work by the division on the San Rafael already doing tamarisk removal. So this is a pre-flood, and they did a study, and Dan Keller talked about this, I think, yesterday, if you had a chance to see his talk. But they did a lot of tamarisk removal. So this is an aerial photo before tamarisk removal and before a large flood event occurred in 2011. And this bottom aerial photo is after that flood. You can see the tamarisk was pulled out of the ground and piled into these piles. And you can also see that after the flood event, we had these areas where the channel really eroded and moved around, and we had some bank erosion, and it helped create some complex habitat that the fish use, like these backwaters. And, so we think by removing that tamarisk, it destabilized the banks, and when this flood came through, it was able to erode some sediment and recreate some of this complex habitat. So we're looking at doing that in targeted areas where we think we can help with this process of bank erosion and creation of habitat. We're also looking at partnering with beaver. We think that the beaver dams, there are beaver in the system, and the fish are using these areas of complex habitat that these beaver dams create. We think the beaver dams get washed out by high flows in this confined channel, so we're looking at using some structures to help keep those beaver dams through these high flows, and hopefully, again, use this as a technique to create habitat for fish. We're also looking at adding wood and large substrate to the channel. Again, where we have wood, it's altering the flow, creating scour holes, and just important habitat for native fish, and the same with large substrates as well. We're also looking at gravel addition, and the idea behind this is that it would be mimicking a tributary input. So where we have the tributary inputs, like right here, they dump in a lot of gravel. This gets moved by high flow events into these bars and riffles. So we're hoping to mimic that by just dumping gravel in at one point and letting the flows move that gravel around. So those are some of the techniques we're using. But a key thing we're going to be doing in this project is implementing those in experimental design. So we're not going to do all actions in all places. And we're going to really test what are the most effective solutions, where we implement them, and so that we can, so when we move forward in this phased approach, we'll be using the most effective techniques over time. And then of course, we have developed an extensive monitoring plan. That's really important. That was one of our goals. Again, that was ingrained from the start of this plan. And so for us, we're going to be monitoring habitat, geomorphic changes, and vegetation changes. And we really set up well for this because we have some great pre-restoration data. So there's been a lot of effort to set up well for monitoring down the road. And of course, the reason for monitoring is that we can then set up the plan as an adaptive management framework, use that information to take a look at our goals, our objectives, and our site prioritization over time, and change those if necessary. And certainly we're putting a lot of work into this plan, and there's been a lot of scientific investigation. So we're hoping to certainly inform future restoration efforts on other river systems through this monitoring plan. So just to summarize and conclude, some of the main recommendations we had and that really helped us formulate this large-scale plan were to develop this overall planning strategy, really follow that through that's out there, and it really helped us plan this restoration project. Another important one was to understand the processes. That takes some effort, but it just helps you formulate restoration plans. And then really another important one was understand constraints early so they don't become an impediment, so you don't have unrealistic expectations moving forward. So I think those are certainly three of the main ones that I wanted to emphasize today. And so I'm getting out of time. So there was a number of people that were involved in this. So I don't have time to thank them all by name, but I'll just leave this slide up and take any questions that you have. Thanks for your time. Yeah, right. So the fish do use the gravel for spawning, and it provides riffle habitat. So the San Rafael is just a really sandy bottomed channel. If there's this hard substrate, it can grow algae and insects, and the fish will feed on those as well. So it provides spawning habitat, but also feeding habitat and that they use as well. Yeah, that's good. That's gravel addition's been done other places. I haven't heard of it being tried in these systems. So we really want to monitor that and just try it in one area and see if it's going to be effective.
To build on that question, how are you deciding which stretches of the river to which treatment?
Yeah, that's a good question. Part of that is that the UDWR has done tamarask removal on land they own. So obviously there's already been tamarask removal. So we're trying to use those areas and not do tamarask removal there, but do some of this beaver addition structure and some of this wood addition structure, and then use those areas to say, well, this is this is what happens with a combination of treatments. And then essentially we're going to apply those techniques where the UDWRs does their work, and we're going to, through that prioritization process, we identified a number of areas where we think this is going to have the most benefit for fish, and we're breaking those reaches up and applying different techniques in different areas and looking at those over time. And those areas where we identified where we'd like to do restoration in the future, but we're not doing restoration now, those will serve as controls where we're not going to do any restoration, so that we can compare the restoration that we're doing to those areas to see, get a better idea of what's happening with the restoration.
You identified the presence of non-native fish as a threat. Are you guys going to do any non-native fish control?
Yeah, that's a good question, and that it really is a limiting factor. So yeah, we are looking at trying to do some non-native removal. We think we can do that because a lot of times the river does go dry, so it gets down to these isolated habitats. So that would be a good opportunity at that time to try to do some removal and test and see if that's going to be an effective strategy moving forward. But yeah, we are certainly looking at that.